morning, everybody, from wherever you are, whether you're sitting in your home office to your actual office or potentially sitting on the beach somewhere. From a nice sunnyish Aberdeenshire this morning, I'm sitting in my home office and I'm Rebecca Allison, the Head of Emissions Reduction at OGTC, and will be the chair for today's session. Before we get into some of the housekeeping that most of us will all be familiar with on the last 15 months or so of Zoom calls, just a bit of a background. Our Tech20 sessions, we normally would have them in our Innovation Hub in our offices on Queen's Road, but like everybody, we are still working and living in a virtual world, and this is the season that we're looking at and focusing on some elements on how does digitalisation, automation, and the virtual world help or hinder some of our working practices within the oil and gas sector and beyond. So if we go to the next slide.
There we go.
There we go. Just for general housekeeping rules, your microphones will all be muted, cameras will all be disabled for this session, and we are encouraging anybody to use the Q&A function within the Zoom platform to log any questions, and I'll facilitate those at the end during our Q&A session. By all means, give us your thoughts, your discussion points, your opinions, or genuine sort of queries and concerns. So we'll pull all of those together and put them through ourselves. Charlie will also be joining us from OGTC, who has an interest in the automation and field of the future. So from our perspective, and also from Elgonda's presentation as well. The session is being recorded, so we will be sharing that through our social media platforms in due course. And we are also having a networking session at the end of this, so there will be a link to the networking sessions in a different breakout room. So we'll publish that in the chat function during the session. So as I've indicated, automation is a key area for a focus for the OGTC and the industry, and hopefully we'll have some insights from Elgonda on how Siemens are pulling all this together. So I will hand over to you, and your 20 minutes starts now, and we'll be strict 20 minutes, we'll cut you off. So over to you.
Great, thank you very much. So good morning, ladies and gentlemen. So before we start with the topic itself, I'd like to describe what we mean when we say autonomous operations. So I think most of us, we immediately think about autonomous vehicles, but there are certainly others as well. So if we take the Mars Curiosity rover, it's not controlled from Earth. The latency in communication is just too long for that. And so it decides by itself what looks interesting, and then it investigates. The second example is an autonomous ferry that's been tested in Finland. It navigates itself between two harbors. It responds autonomously to weather conditions, and it also avoids any incursions in its path. But an elk swimming in the sea was a little more than it could cope with. So in the end, AI can only respond to what it's been trained on. Now, I would describe this level of autonomy as do what needs to be done without human input. And this is not what we will talk about today. And I don't believe that this is a realistic target in the short term for oil and gas. Nevertheless, if we can de-man offshore facilities, even just partially, we know that we can reduce OPEX and enhance safety. And the OGTC, Siemens Energy, and most oil and gas operators are actively working on solutions to deliver this. I know of at least one that has set a target for itself to reach unmanned operation of a Greenfields FPSO by 2030. So a very ambitious target. Our current focus, which I think is a more realistic one, is low-manned operations, not fully unmanned, as a stepping stone then towards autonomy. So what we aim for is to do what needs to be done with mostly remote human input, as opposed to with no human input. When we started this work, we challenged ourselves to target brownfields. And I know that there are inherent constraints in how far you can go with brownfields. There's no one-size-fits-it-all solution because you have to work up from the equipment and the automation baseline that you have. But what is a bigger challenge than technology in brownfields is the business case and the changes you need to make to your established work processes. Now, the end state will look slightly different for each facility, but what you can standardize on is the approach or the methodology to tackle de-manning. And that is what I would like to focus on today. Our second objective was to move to what I would call a low-touch maintenance regime, where equipment would only need human intervention once every 6 months or once a year if possible. And we limited our work on this topic to compressors and turbines where Siemens Energy is the OEM. And getting to a 1-year target was not really too difficult for the core rotating equipment, but it's much more of a challenge for the auxiliary systems like the dry gas seals, lube oil systems, and the like. The third target that we have was to have 50% fewer operations and maintenance people offshore during normal operations. This for the entire facility, not just the rotating equipment packages. And depending on the facility, we were able to reach around 30% on an FPSO and 50% on a production platform. But you will have higher staffing peaks during your maintenance campaigns. So perhaps a better metric is that we estimate we can save between 10 and 15% of inherent maintenance hours. And when we developed the solutions for this, we considered digital, automation, but also design changes to the physical equipment. And you need the combination of the three to move closer to low-manned operations. Now, before I start talking about the various components, let me just make an observation about the value of de-manning. When operators consider this, they do so primarily to reduce OPEX and to improve safety. But the solutions that enable de-manning also deliver consequential value, like higher uptime, for example, and lower emissions from fewer helicopter trips and flaring. And when you calculate your business case, keep in mind that you should consider the benefit from that as well. So let's now look at the various components of Manning Modernized. 2 general comments first. For brownfields, you need to actively manage the changes that the manning will make to your work processes. And I'm talking here about this comment that I have here below. Now, one operator in the North Sea told us that they have actually suspended all of their digital projects on their brownfield platforms because it is just too difficult to get their crews to accept and to adopt the new tools. So a word of advice, and that is get change management experts involved on your project right from the start to work with you. The second comment is about data management. Now, digitalizing all data on the facility retrospectively is a huge effort. So my recommendation again is digitize as and when you need it. So as a minimum, you need to look at your P&IDs and equipment data sheets, and these must be up to date. I would also highly recommend that you invest in a reliability-centered maintenance study. This will help you identify failure modes and effects, and also their criticality and frequency. This is important because there's a tendency to just add additional layers of maintenance activities over time. We did a study on an FPSO in Brazil, and without any new technology, just optimizing maintenance practices, we reduced inherent maintenance hours by 25%. Now, that's perhaps an extreme example, but it nevertheless applies to all mature facilities. An RCM study is also a really good way to identify the high consumers of maintenance man-hours on your facility so that you know where you have to focus your de-manning efforts. Now, the first objective that we would have is to de-man your normal operations. And as a prerequisite for this, you need connectivity and cybersecurity. Cybersecurity is of the utmost importance. It has to become part of our DNA, just like HSE. And just like HSE, it has to be managed continuously. The answer is not to lock down everything, because if you do that, you lose a huge amount of the value that you can get from digital. So I would encourage you to engage your IT teams with experts in industry and define a policy that will allow safe connectivity to open up the door to value. Now, when it comes to connectivity, I want to combine a discussion or some comments about that with remote control. I don't know how many operators you would have on your platforms, but typically it's 2 day shift, 2 night shift, maybe 2 standby. And these are really easy roles to move onshore. But for that, you need connectivity. And we unfortunately don't have the luxury of a fiber optic ring cable as in the Norwegian North Sea. So we need to make another plan. 5G, I believe, will be a big step change, and it's moving ahead fast enough that it's something we can actively consider. With 5G opening up connectivity, though, there is still a challenge of multiple older generation control packages offshore, and it's mostly not cost effective to retrofit a full modern control system. But what we have done is to leave the I/O cards and controllers in place and then pull all of the control signals into an onshore SCADA system. And we can do that on process without a shutdown. Now, you may not know this, but Siemens Energy operates about 34 power plants globally, and we have really good experience of installing such an overarching SCADA in remote control centers. And in one of the plants in Argentina, we actually remotely control via satellite because the controllers are still on site and continue to respond sub-second. Now, granted, these power plants don't process hydrocarbons, but all of them have multiple turbine trains, and you will probably know how unforgiving turbine controls are. So I still think it's a good reference case that we can consider for oil and gas as well. Now, the next aspect I think we need to consider is when you want to de-man is to remove all routine manual tasks. People always jump to the conclusion that you need to use robots and drones for this. But the technology for that is still developing. And on brownfields, you have a lot of challenges because it was never designed to provide accessibility that you need for robots and drones. You can do a lot without it though. So we did an in-depth analysis of all of the routine tasks for our aeroderivative gas turbines. And we started with an RCM study that I mentioned before. And that alone helped us to reduce prescribed routine tasks from about 240 in a 6-month period down to 158. It's a big reduction already. And for the remaining tasks, we could replace them relatively simply. And the first thing we needed to do was to expand some of our control system automation. That was relatively simple. The second was to add a couple of more instruments. It was mostly around thermocouples. Downstream of the relief valves, you could replace that with microphones as well. We added a couple of filter delta P measurements, and then a few multi-mode IoT sensors that typically measure temperature, vibration, etc. You can or cannot add a gas sniffer as well. So a couple of instruments, not too much. And then we deployed static cameras with image analysis. We looked at 3 thermal cameras and one to analyze for leakages, liquid leakages for puddles on the package floor. The fourth consideration was the physical design changes that I talked about before. So there were some modifications that needed to be made to the seal air system. We needed to install HEPA filters and online water wash. Now, it depends. This was not a requirement for all installations, but those were the three that were mostly required. And the last item was online oil analysis. Now, again, this was not a requirement everywhere, but in some facilities, we need to look at acidity and water content measurement and upgrading magnetic chip detectors in the loop oil system to quantitative debris monitoring. And the last item in some cases was adding a larger loop oil tank. So the changes that you make to routine manual tasks, that becomes much more difficult if you want to go for full demanning. If your focus is just lower manning, then the 80-20 principle certainly holds, and you can get 80% of the benefit with 20% of the much less complex modifications. Now, the last bubble you see here in the operational phase is efficient operations. That's not necessary to demand per se. It takes us more into the full autonomous operations domain. So I will skip that for now. And I will also skip shutdown because autonomous shutdown is nothing new. We've been doing that for a long time. Now that then brings us to maintenance. For maintenance, the first objective is to remove your full-time offshore maintenance technicians and then replace them with high-intensity maintenance campaigns. But to do maintenance campaigns, you need trustworthy predictive maintenance so that you don't have unplanned failures in between your campaigns. Now, we pre-built about 3,500 unique failure modes on more than 1,000 different equipment types into an analytics engine so that pervasive condition monitoring is cost-effective for the whole plant. And we've had some really good results for it. But I have to say, for more complex systems, the lowest risk is to have live connectivity between the facility and the OEM so that they can use their experience from their entire operating fleet to do dynamic lifing. Less planned downtime here is normally associated with better equipment and material choices. That's often not a possibility to change in brownfield, so it's less important here. It's a very important lever for brownfields, but for the purposes of this discussion, I leave that be. That brings us to the last component or the last aspect, which is connected worker. And this is a low entry point. It's something that can deliver value to all facilities and a really good place to start if you want to look at demanning. What you want to allow the people on the facility to do is to take on more challenges and do more work for which they are not necessarily fully skilled. So you want to do more with the people that you have. And for that, you have to connect them to remote experts, either your own or the experts from the OEMs, so that they can help them with root cause analysis, give them guidance if, for example, there's a fault finding exercise or they need to go through a work sequence or a maintenance sequence that they would not necessarily do. There are a variety of these solutions out in the marketplace, but I would really encourage you to start there. It's totally possible to handle connected worker solutions via satellite. So having a fiber optic or a 5G connection is not a prerequisite for that. Now, this brings us back to startup. So we know how to do shutdowns with no human intervention, but we are not that great at doing startups autonomously. And we have now done a lot of work to extend the one-button shutdown principle to a one-button startup as well. And we are implementing this on a major production scheduled for first oil in 2023. Now, you still need to pre-start the emergency power system, essential services for seawater, firewater system, and the ICSS. But for everything else, the startup sequence will be automated. Now, on brownfields, you have manual valves and resets. So you can only automate operational sequences in between these manual steps. But nevertheless, it is a very possible activity that you can go for to reduce the need for people to physically be on the platform and control it from there. Now, an interesting point that I didn't mention when I talk about remote control, for many of the plants where we do remote control, we've installed critical action panels spread throughout the actual plant itself so that field operators are able to initiate a shutdown if that is necessary in their judgment. So it does not have to be remotely connected to the control room that is offshore. As I said before, looking at these solutions that I've described at a very high level, even on brownfields plants, we are able to reduce the inherent maintenance man hours by anything between 15 and 25%, and reduce the people that you need on board for normal operations between 30 and 50, closer to the 50 if it's a platform rather than an FPSO. So with that, my time is almost up. I would like to open it up for questions, but I hope this gives you a good overview of how to approach your demanning initiatives and the different aspects that you should consider with today's technology if you want to start a demanning initiative of your own. Thank you.
Thank you for that insightful approach. So use the Q&A, please, to put any questions or comments into the panel, and I'll facilitate. So kind of to kick this off, we've got 20 minutes for this session as well, and I'll bring Charlie in for a couple of bits and pieces too, because we've been working on this type of concept for Field of the Future work that we've been doing, and also we have a big program looking at automation and smart facilities through our offshore energy program. And I think you've touched on it a few bits throughout your sort of presentation. And low manning, fully unmanned platforms, is it still aspirational? We've been talking about this as an industry for a long time, and maybe the technology has not been quite ready yet, but in reality, are we ever going to get there fully to the low manned or unmanned automation that we talk about? Or is it going to always be that aspirational? We'll never quite get it.
So I could share my opinion, but it would be great to hear from the audience as well. I think it really depends on the complexity of the facility that you are talking about. We already have fully unmanned wellhead platforms. That's not aspirational anymore. In the North Sea, for the new NOAA and Fulla field developments, part of that will be normally unmanned. The main production platform, they have really stringent targets to reduce the people on that platform as well. If you look at something like the Woodside Scarborough FPSO, a normal FPSO would have staffing of anything between 100, 140 on the really big ones. They are staffing that FPSO with 12 people so that they can vacate or evacuate them with a single helicopter trip in case of cyclones. So in my view, it's much more a reality with greenfields, because you can make your equipment, materials choices, you can define your layouts to make it easier to demand. So I'm pretty convinced that we will get to unmanned operations for platforms by 2030. I probably think FPSOs by 2030, especially deep water FPSOs, that's very ambitious. When it comes to brownfields, I think you can get far. The technologies that we worked on we're not rocket science. It's all technologies that's available today. And technology-wise, you can relatively easy get to 50% less. The challenge there is, do you have the business case, right? Because many older platforms don't have a long lifespan left. So you need to consider that. But technology-wise, I think we can do it.
Charlie, from the OGTC's perspective and some of the discussions we've had with operators and that, again, do we think we've maybe missed the opportunity? And I think we've talked about this on this sort of late life and ultra late life assets, which is the majority of the UKCS. But are we in the position for new field developments to really go down this route as well?
I think there's a huge prize if we can. My interpretation is that as Elgonda said, I don't think there's a huge technology gap. But I think there is a big gap in the adoption and integration of those technologies together. I think there's probably, I mean, obviously there's the economic side of it as well, but I wonder if there's also more of a culture thing within, all companies. Obviously there are huge risks at trying out new things, and this is, a new thing for this industry, maybe not other industries. But when you think about all the other things that are automated, I mean, when we fly, well, back when we did fly, you wouldn't have the pilot in control of it the whole time. That's literally have something called autopilot. So I mean, I'd be interested to hear your thoughts on this, Elgonda. But do you think there's like a mindset culture piece? Is that maybe more of a barrier than the kind of raw technology gaps?
Yeah, definitely. We see that it is really hard for facilities with very embedded work processes to now think about how can they do things differently. And that is often thanking some of the good digital and other initiatives that are being run at those plants. Interestingly, some of the newer greenfield developments, when they hire crews, they seed the crew with a number of really experienced people, but 80% of the crew is younger generation people that have the training, but not necessarily the embedded ways of working of the old timers that have been doing this for 30 years. So they don't come with a baggage of this is the way we've always done it. And I think younger generation people are traditionally more questioning anyway. And they are seeing much more agility in that workforce mix to change things and to still stay safe. Of course, that is without question, but just to do things differently. And that's why I made the comment earlier. If you want to work on brownfields, bring in experts that understand how to do change management. Because we're engineers, we think you deploy good technology, you give the people 3 training sessions, and then they will just do it, but they won't. And that to me is the biggest question. I think we have to accept that as engineers, we don't have all the answers here. We have to go to the social sciences guys who understand how to change people's mindset, and this needs to be a joint effort with those types of experts.
Yeah, no, absolutely.
Sorry, Charlie. So just keeping on that theme slightly, because there is a couple of other questions that come in, but I'm going to keep on to this on the human factor side. Is there a piece, and it's always a sensitive subject, around job retention, upskilling, and is there maybe a barrier, reluctance again because of the potential, the perceived obsolescence of some jobs, that side of it, which is obviously a very difficult subject, and I know there's always a bit of a debate on whether automation will replace people, and is that a good thing or a bad thing from an economic point of view for the individuals.
So when we look at the analysis of the staffing, I mentioned 30 to 50% saving of people offshore, but you would pretty much still need those people onshore to then run through the maintenance work when you do the maintenance campaigns. When I said we can save 15% of the inherent maintenance hours, that's true. So that could be a reduction in manpower. But the biggest saving is that you don't have to continuously pay for the offshore rates. And you can only pay offshore rates when people are really offshore. And safety, you take people out of harm's way. And we know that a large proportion of incidents offshore are caused by people doing things perhaps not quite right. So it's also safety of the plant. So I think the perception of, oh, a lot of people will use their jobs, I don't see that. I think it's more where the people are based and the OPEX savings of having people based onshore rather than offshore.
Yeah, and I think we've seen that from some of the work we've been doing as well. It's about upskilling, giving people choice and different skill sets. And there's a lot of support out there for the existing workforce and how they can transition to potentially new roles. So we have seen that as well. So it is an area. And again, there's more and more people don't want to work in harsh and remote environments. And if you can do it from onshore and have the same sort of skill base, then it's a win-win for everybody, I would hope. Going on to some of the technology side as well. So Ian's raised a point around the whole connectivity piece, and also, you know, we know that the fibre side of it, and then potentially 5G. Any thoughts on the sort of the Earth orbit systems that Elon Musk, Starlink, and some of the newer types of connectivity? Have Siemens had any thoughts on that one?
We are aware of that. I think there are a couple of companies that's perhaps more advanced than Elon Musk in this space, and that have some well-developed plans to roll out satellites that can be used in the North Sea, in the Gulf of Mexico, etc. It's still expensive. So I would say that 5G is probably in the short term for us the best potential, but it's also technology that develops very quickly, right? So we should not discount the fact that the low Earth orbiting satellites can come in and quickly change that picture. It's definitely something we're keeping an eye on.
Yeah, likewise with that. Stephen Ashley, who heads our offshore energy program, is looking into that in his team on the different solutions as well. So it's been interesting space.
Yeah. One question that I had, and it sort of follows on from a question that Brian's put into the chat. CAPEX is still king. The whole life cycle cost aspects make sense, but do you see the industry taking this on? Is CAPEX still king? Because from the work we did on Facility of the Future, there was actually quite a big emphasis put on OPEX. More than CAPEX. Obviously, CAPEX is important, but it was actually OPEX that people seem to be most interested in. Do you think that's correct, or do you think that I've got that sort of completely backwards?
No, it's an interesting question, because when you speak to new greenfield project teams, they will tell you, oh no, we're looking at total life cycle cost. That's what we decide on. And then typically, as it comes closer and closer to the final investment decision, the balance swings more and more back to CAPEX. And I don't know whether it's just how decisions are taken in these companies, that they are really still discounting the life cycle cost component, or whether it's the project teams that just feel comfortable by driving down CAPEX. It's probably a combination of both. But I think there's a lot of education that as an industry we have to do with operators and with the procurement teams of operators to change the evaluation criteria when they engage with vendors, to not just ask what it will cost now, but what it will cost over the life of the facility or the equipment or whatever it is. So yeah, I see some good signs, but I haven't seen actually people taking that step and saying, yeah, we will invest more in CAPEX because we'll get the savings back.
Right. Yeah, fair enough.
And I think to follow up on sort of Brian's comments as well that he's made around the whole brownfield inspection being a large manning activity and robotics. We touched upon about our brownfield sites are not typically designed or can facilitate some of the robotic solutions coming through. And I think from our perspective and what I've seen, because I have the asset integrity type background, is very much there's going to be a mixture of the rockets, whether it's from drones to crawlers to the larger sort of ground-based or obviously the subsea autonomous type systems. But I think from my perspective, what I'm seeing is potentially more traction in the sensor and remote monitoring ahead of intervention, because I think the intervention side has got a long way to go, and we do have some trial activity going on with some of our partners on some of the robotic solutions, but the remote sensing and monitoring, I think, is going to be the ones that will really see traction. And there's new technologies, especially as the connectivity and the cost is coming down. So again, is that something that you guys are seeing as well?
Definitely. So we looked at the drones, the robots, etc., but we really did not think that that was such a viable option for brownfields. So it was much more about putting in the right instrumentation in the right place. There's a lot of IoT instrumentation that you could retrofit. Obviously, it will not measure things like pressure or flow that is invasive. So you would still need to do that when necessary. And you can also do a lot with static cameras. Now, if you put in static cameras, you have to be really smart about where you put it. But it's not so difficult. It just needs more thinking. Often facilities already have some cameras that you can make use of, because it doesn't have to be super high resolution. You really just want to pick up a change. You don't necessarily have to identify exactly what the root cause of the change is with a camera. You just need to say, there is a change. Now go and send somebody out to look what it is. That is what our people walking around mostly do anyway.
So Roger's put a bit of a question in there. And
you can always rely on Roger.
Yeah, we can rely on Roger. So around the future of the industry or the UKCS, which is obviously much looking at alternative uses, whether it's carbon capture and storage to the hydrogen production side. So his sort of question is, what is the number one ask to the industry if we are going beyond traditional oil and gas operations and potentially repurposing and going to 2050 and beyond with the new era? What would your number one ask be?
Well, I would ask the industry. Oh, I think I would certainly go back to say, please work with your teams to look at life cycle cost. Definitely. That would already make a huge difference in how technologies are selected and viewed, and can move us ahead a lot quicker. The second would be to look at your people and skill them up to be ready for the energy transition. I think when new technologies like carbon capture, etc., are going to be deployed, they will come with embedded digital solutions, right? You will not have the option of buying, let's say, a dumb CCUS or whatever the carbon capture technology is that you want to deploy. So make your people ready to use it and use it effectively. And for me, those are the two key ones. The technologies are pretty much there or thereabouts. But the first two to me are the biggest steps we have to take.
Charlie, what would your ask to industry be? We work with industry a lot, so what would you be?
Oh dear, I need to be careful I'm not too controversial.
Roger, to give us that.
So I think to me it comes back to the culture piece. And I think that speaking as an engineer, that's a very difficult thing to qualify. I like working with numbers and physics and sciences and stuff like that, but with the kind of social science piece, I think it's very difficult to quantify. But I think it is just so important for the adoption of the new technologies and get it. I mean, obviously, we spend a huge amount of time trying to get support from the end users, which are normally operators, for our technologies. And I think it is just so important that you have that end user support and buy-in early on in the technology's development, because that just helps the adoption so much more later on. So yeah, that would be my ask of industry, to keep an open mind and to support the stuff that you want to see brought through to industry.
Perfect. I think Ian's quite put a topical question in around the environmental. So do we measure, or to elongate, do you measure the environmental benefits as part of the net zero piece, which is obviously very topical for us, especially myself, as part of emissions reduction. So is that something that we're doing with some of these projects?
Yes, but I would say that just looking at demanding doesn't go far enough when you want to tackle decarbonization. There's a lot that you should be doing to decarbonize that goes way beyond demanding. So you need to look at the efficiency of your power generation equipment. You need to look at fugitive emissions. You need to look at it much more holistically than the piece that we tackled here for demanding. And there's a massive amount of work that's going on specifically in the area of decarbonization.
Yeah, no, absolutely. As we used to say when you worked in marginal developments, and I think as we say kind of now in emissions reduction, there is no one silver bullet here. Yeah. Otherwise we would have all gone after it. I do think that the whole demanding piece is a big part of it, and it's a big enabler for a lot of other pieces. But us humans are very kind of carbon intensive. So if you can remove some of us offshore, I think it's a big win.
Definitely remove it offshore, and also the fact that to remove people offshore, you need to be able to run your plant more reliably. And if you have fewer trips, you have fewer flaring, fewer emissions. So those two together makes a big impact already.
Yeah. Oh, and that's a 3, 2, 1.
So our Q&A session is now over. I encourage those that have time or still have some comments. I see Tom and Brian have a few bits and pieces still in sort of the chat, that we would invite you over to our networking session where cameras could be on and we can have a bit of a conversation discussion to carry on with this. So the link is in the chat. So if you click on that link, it will take you into the networking session, and we welcome everybody to come along and either just listen in to the chat that's going on, or feel free to come in and contribute to the ongoing discussions, which has been very interesting and a difficult topic in the sense of it's not an easy win for lots. There's lots of moving parts with it. So click on the link and come over to the networking session. I'll just join there now. So I'll disappear off and we'll see you, as we say, on the other side.
Thank you.
Thank you, everybody.